So make them as 1 unit, 5 boys and this 1 unit, 6. 6 factorial into internal girls can be arranged in 5 factorial. 6 factorial into 5 factorial by 10 factorial. This is the probability of getting all the girls together. So probability is simple, whatever the things. Denominator first, total possible ways of writing, whatever the condition. So that is the total number of permutation, total number of combination. Numerator is whatever the favorable case to us, whichever the favorable case to us. Okay. There is an eye infection for me. I'm not able to see the screen actually. So total number of cases in the denominator, favorable cases in numerator. So probability in simple word, if you ask me, that's it. Yeah, we are going to study many things, but when the statistics and mathematical reasoning, that will be taken care better. Those small. Actually, what is the, as per the thing is, after this one, some 2 days sets, 2 days mathematical reasoning, etc. there. Okay. So your statistics, mathematical reasoning, and other things, we are given around a week or 10 days time for that one. Actually, we will take care of. Don't worry about that one. Okay, but these are the major syllabus for that one. So the probability is simple line. What is the probability we are talking about? Number of favorable cases by total number of cases. I am not, sir, I'm not perfect with P and C. Yes, you have the great advantage of getting perfect with this permutation in the probability, because in the probability also we are going to talk about same arrangement. Instead of saying arrangements are combinations in the permutation combination, here we'll use the word events. We call it as event. Number of favorable events, total number of events. What is a simple event? What is those things? Okay. Right. So, and I don't know how many of you checked your OneNote app. Already the probability notes was uploaded. Yesterday I uploaded with the questions also, basic level questions. And one thing I want to tell you, whether you take permutations, combination, or probability, okay, whether it is permutation, combination, or probability, one important thing is the chapter is equally easy and equally difficult. Simple, it depends on the, not on the chapter wise, it depends on the question wise. It depends on the question wise. Okay. And last week on Friday, Saturday, one of the question, one student asked and I didn't do that one. I told you people that I'll come back to that one, that assassination, that question I'll take up in this probability and we'll discuss. Okay. So whatever you have done in the permutation combination, you can convert into probability and do this one. Okay. Right. When will our college will open? Good news is just now before in the morning, when I'm going through the newspaper, just I'll go every day morning in the mobile, the headlines of the newspaper. And the thing is, they mentioned clearly all the educational institutions, right from LKG or UKG nursery onwards, can be opened from September 1st. The government has given that clarity. So let us wait what our management is thinking about this one. So since the decision seems to be taken yesterday evening and it has come today now, so you might receive the calls in this week to report to the campus by Saturday type of thing, so that you need not miss your Sunday exam type of thing. I'm expecting, I'm not sure. Okay. So I'll switch off my video and so that I can switch off these lights also, which is troubling a lot me. Okay. So who is this red mark fellow? What is the problem, red mark? Sir, then what about the batch shuffling? Maybe when you are coming here, they might have shift, because in this batch supposed to be around 140 people. No, they might make it as two parts. Okay. But one thing, Nana, once the syllabus is over, so anything is okay for us. Don't worry about much about that. Okay. Right. See, in the probability is random experiment. Okay. Random experiment. So I need to switch on, otherwise I can't explain quickly. See, random experiment means you are performing some activity. Result is two things, two or three, whatever. You know the result. So from these only result is going to happen. I'm teaching you people. I know the result. Set of A, set A, where the people are understanding what I'm explaining. Set B. Set of people are understanding of A and not understanding of A. Set C. People are not understanding at all. Section D. Set D. People are not listening at all. Obviously, you people, one of this category, maybe any other thing. People, set of people switching on the video and happily browsing through mobile for WhatsApp and what is that, Instagram, etc. Okay, so one of these things are possible. So that is the random. Now you take a tennis ball and hit the ball, throw that ball towards the wall. So the ball surely will come back. There is no alternate to that one. It will not be random experiment. When you're throwing a dice. Dice, you know, 6 faces with 1, 2, 3, 4, 5, 6. You know, one of that comes. So such things are called the random experiment. Random experiment. Each possible outcome is called out. Each possible result is outcome or simple event they'll call. Okay. Oh, somebody is, when I said September 1st onwards, the colleges are open. Moodo muppu tajam. Okay. September lone. Oh, okay. No, obviously, no. See, in the paper, third wave is given. Yeah, see, we have to do our thing to make all these gatherings, etc. Then only that will go to the peak level and then will come down. Okay. So you people should be self-protected, self-care. Okay. You should have your own mask and sanitizer, etc. Okay. So you cannot wait for these things, Nana. These are going to happen. Okay. So when the virus comes, it will not go that easily, but we can't spoil our lives. No. Okay. It's affecting a lot, particularly people like you, young generation people. Okay. You lost your complete skills, writing, reading, etc. Okay. So don't worry about the third wave or fourth wave. Once the third wave comes, automatically fourth wave. These medical people also say they'll give the care properly. First wave, these many days. They're giving the schedule, like how we are giving the first phase revision, second phase revision, third phase revision, JEE main first phase 1, phase 2, phase 3. They are also giving. So let us leave those things and continue. Okay. But yes, everyone has to be. We need to take care of ourselves. Okay. No one is there to take care. Right. So this is the random experiment. So random experiment has more than one possible outcome. Not possible to predict the outcome in advance. Some of the examples are tossing a coin, throwing a dice, drawing a card from well-shuffled pack of 52 cards is a random. Now, what is the outcome and sample space? A possible result of random experiment is called the outcome. So when you are throwing a dice, possible outcome is 1, 2, 3, 4, 5, 6. So if you take each one is the outcome. Each outcome, each result is an outcome. And set of all possible outcomes is called the sample space. Okay. So what is that one? Set of all possible outcomes. Set of all possible outcomes is called the sample space. Okay. Each element of sample space is called the sample point, or also simple event also. What they call? Simple event. Sample point or simple event. Okay. So here this is. So what happened? All possible outcomes you need to write. You need to write all possible outcomes. Now, 2 coins, a 1 rupee coin and a 2 rupee coin are tossed. What is the sample space? What is the sample space? So I will write the sample space as like this. Here 1 rupee coin, here 2 rupee coin. Okay. You will be getting the possible outcome is head and head is possible. Head and tail is possible. Tail and head is possible. Tail and tail is also possible. Okay, this is the sample event. Now just I'll tell you, these are all possible events. Now if I say number of ways of getting 1 head plus 1 tail. So what happened? These are the 2 things. So if I I say event E. So what is the probability of E? I'll say number of favorable cases. How many favorable are there? 2 are favorable out of 4. So answer is 1/2. That is the probability. That's the probability. So simple. Okay. Now, look at here. When a coin is tossed twice, and if head appears in the second throw, then the dice is thrown. Write down the sample space. So you need to write it carefully. A coin is tossed twice. If the head appears in the second throw. So first one is head, tail and tail. no problem. Head, then next toe is toe. Next throw is tail, no problem. Tail, you draw head. Then you need to write the, what happened? Dice. So what will happen? TH, 1 is possible. TH, 2 is possible. TH, 3 is possible. TH, 4 is possible. TH, 5 is possible. TH, 6 is possible. Now head, head. Then because it has head, because if head appears in the second throw, the dice is thrown. Head, head 1, head, head 2, head, head 3, head, head 4, head, head 5, head, head 6. Okay? So write all possible. So how many things are coming, you need to check. If it is the second throw is the tail, you need not worry. If it is a head, then you need to go for the throwing the dice. Now, we are moving to the next one. Event. Read it carefully. So please read out what is the event. So sample space, any subset of sample space is called the event. Okay. So when you are consider the experiment tossing a coin 2 times. So what is the sample space? H, 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 T, T, H, T, T. Now you can take the event as getting a head and getting a tail. Get one event. Getting 2 heads, 1 event. Getting 2 head tails, 1 event. Okay. So that's, you can take any one as the event. Number of tails is exactly 2. This is a corresponding sample space. Number of tails is at least 1. This is the sample space. Number of heads is at most 1, is this one. Second toss is not a head. Number of tails is at most 2. Number of tails more than 2, null set. Any subset E of the sample space is called the event. Any subset of the sample space is called the event. Next, the maximum number of events which can be associated with the experiment is, okay, see, if experiment is repeating for n times, where n is the number of elements in the sample space. So number of elements in the sample space is equal to n1, n2, etc. N is there, a1, a2, an. Now what happened? How many events are possible? Out of this, taking 0 element, 1 element, 2 element, up to n element. So 2 to the power of n. In throwing a pair of dice, write down the two possible events, even sum of the numbers. So first of all, pair of dice. How many outcomes will be there in the pair of dice? How many outcomes will be there in the pair of dice? First one, 6 outcomes. Second one is 6 outcomes. So 6 plus 6, 12, or 6 into 6, 36. Which one we need to take? You need to take 6 into 6, 36. Okay. So on the first one, 1 will be there and it will be mapped with all the 6 elements. So it will be like 1, 2, 3, 4, 5, 6. And second one, 1, 2, 3, 4, 5, 6. So 1 is going to all these 6 events, 6. So 36 outcomes are there. So out of these 36, sum of the numbers appears on both the dice is 7. So what are the event E1? 7 should come. On the first one, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Sum of the numbers of an appear on both the dice is divisible by 3. Divisible by 3. So minimum what happened? Total will be, if you're taking at the totals, actually it is minimum is 2, maximum is 12. Yes or no? 1 plus 1 is minimum, 6 plus 6 is the maximum, 12. So now what is, how many are required? Divisible by 3. So sum should be divisible by 3. 3 or 6 or 9 or 12. These are only the possible. 3. 1 comma 2, 2 comma 1. Next one 6, 1 comma 5, 2 comma 4, 3 comma 3, 4 comma 2, 5 comma 1. Next one 9, 3 comma 6, 4 comma 5, 5 comma 4, 6 comma 3. Next one 6, 12, 6 comma 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n of E2 is equal to, how many we got? 12, right? 12. Now, if you tell me what is the probability of E2, though I haven't discussed probability, but I want to enter. What is probability of E2? Probability of getting the selected event whose sum is divisible by 3. So total number of favorable events. Any one of these 12 are favorable? Yes. Out of total, how many are there? 36. So this probability is 1 by 3. I haven't discussed probability, but this is what the concept is. Very simple concept. Okay. So you write the sample space. You write the event. Event is the subset of the sample space. Okay. Okay. Next one is occurrence of event. Consider an experiment throwing a dice. Let E denote the event. A number less than 4 appears. If actually 1 had appeared on the dice, then we say event E has occurred. As a matter of fact, if outcome is R2 or 3, we say the event has occurred. Anything satisfying our condition is event has occurred. And the event E of the sample space S is said to have occurred if the outcome W of the experiment such that W belongs to E. If the outcome W is such that W is not belongs to E, that event is not occurred. Whatever you are writing, occurring or not. If it is a part of the or a event, it is occurred. Otherwise, it is not occurred. There are the two things. Impossible events, sure event. Impossible never happens. Sure event always happens. The empty set pi and the sample space S describe the events. In fact, pi is called the impossible event and S is called the sample space is sure event, because when you are writing the throwing a dice, outcome is 1, 2, 3, 4, 5, 6. So I'm writing that sample space as the event. This event is always sure event. One of those things are going to happen. You are throwing a dice and you are taking the event sample space event as the null set. So something is going to happen. So null set is impossible events. So look at here. Samp 1, 2, 3, 4, 6. Let E with the event number appears on the dice is multiple of 7. First of all, 7 is not there. So how you'll get the multiple of 7? So it is impossible event. Yes. Simple event, you need to quickly need to have the wording on these things. Simple event. Compound event. Exclusive events. Exhaustive events. These are the things we are going to talk about. Simple event. If an event E has only one sample point. Sample point means already I told you. That is when you're throwing a dice. 1, 2, 3, 4, 5, 6. If you take each one of them as the separate thing, that is the simple event. Okay? Only one element will be there in that one. So that is called the simple event or elementary event. In a sample space containing n distinct elements, there are exactly n simple events. See, when you are throwing a 2 coins, what happened? Head, tail, tail, head, tail, tail, head, head. These are the 4 simple events. 4 simple events. Compound event is which is not a simple event. Compound event means which is not a simple event, but the subset of the sample space. If the event has more than one sample point, is called the compound. See, I'm not stressing too much on this one because these are self-explanatory. You can read, okay? And for this week, your mostly exam syllabus must be on the complete permutations and combinations, okay? What is the sample point? Simple event beta, whatever the experiment you are doing, each and every simple outcome is the sample point or simple event. When you are throwing a dice, 1 or 2 or 3 or 4 or 5 or 6. If you are picking a playing card, 52 cards will be there. Picking each card itself is the simple event or sample point. Why is somebody showing monkey? Charan, why are you showing monkey? Sujan want to offer coffee to me. Offer some eye drops better instead of coffee. Seems somebody is showing the rains. Raj Siddharth seems to be is taking the shower and listening the class, I think. Huh? Or it's outside raining. Right. All these things only couple of days. Once you come here, ma'am, I'll tell you. Because before you people are leaving, I told you, if the online classes comes, what are the things, how you are going to study? Everyone in this class, most of the people promise me that you will do make everything. So I'm going to check the notes. The first thing I'll do is I'm going to check your notes. Okay? I'm going to check the notes first. Because you cannot say last time you people said no, we didn't understand or we didn't maintain the notes, etc. But already you got experience this time. Okay? And in this class, people who were going for the means of homesick holidays, you went for the homesick, no, actually went as a homesick, and then it is turned into this lockdown. I told you, better you carry your textbooks and it may come at any point of time. Right. So compound event is this one. Okay. Algebra of events. So this is more like your set theory, beta. A quick recap on your set theory type of thing. Complementary event. Okay. Uh, frankly speaking, this complementary events. Yeah, somebody suggesting to remove the virtual background. Okay, let me. Okay, this one also I'll make it dull. Yes, this is better. What is the complementary event? Complementary set. So this is the sample space. This is the event. Complementary event is A bar or A dash or AC. Okay, that is sample space minus A. In the set theory, you'll write complementary set. Means set A is getting at least one head when you're throwing at two coins. A complementary, getting no head. So this is the sample space or universal set. In the set theory language, it's a universal set. This is A, so the rest of the things are A complement. S minus A is the complementary set. Complementary set. For us, sets are not completed in class 10, it was there beta. Otherwise, you look at here, you'll understand. It's a simple chapter. Okay. So this is total set, universal set minus set A. You will be getting the complementary set. Next, event A or B. Event A or B. So that means A union B. What is meaning of X belongs to A union B? X belongs to A or X belongs to B. If X is there in A or X in B, no problem. So here this is the sample space. This is A. This is B. You are going to get this one. And N of A union B. Number of elements in A union B is equal to N of A plus N of B minus N of A intersection B. Why? Because this is in A, this portion is coming, in B is also coming. So we are considering twice this one. So I'm subtracting once. Event A and B, that is A intersection B. A intersection B means when you are writing this one sample space, this is A and this is B. X belongs to A intersection B. That means X belongs to A and X belongs to B. So which is this one? This is the intersection. If A intersection B is a null set, if A intersection B is a null set, we call A comma B are mutually exclusive. Mutually exclusive events. Means occurrence of one event preventing the occurrence of the other event. Okay, mutually exclusive events if A intersection B is equal null set. Here A union B is equal to sample space, then we call it as exhaustive events. Exhaustive events. So union of two sets is the sample space, that is called the exhaustive events. So A or B, A and B. This is A union B. This is A intersection B. Okay. A but not B. A, it should be A but not B. So that is, we call it as, we can say it as A union B prime, you can write, or you can write A minus of B, you can write, or you can write A minus of A intersection B, we can write. And number of elements of A union B prime is equal to N of A minus N of A intersection B. Okay. Neither A nor B. Neither A nor B. So neither A nor B is A union B whole complement, or which is equal to A complement intersection B complement. So neither A is possible nor B is possible. Okay. So number of elements of A bar intersection B bar is equal to number of elements in S minus number of elements in A intersection B. And please understand one point here. If B is subset of A, N of B, A minus B, N of A minus B is equal to N of A minus N of B. Okay.